Okay, so in this video, I'm going to answer the question, but why? But why what? But why is cosine an even function? But why is cosine even? Cosine being even, it means that the cosine of minus x equals the cosine of x. And at the same time, I'm going to answer the question for a sine, which is, but why is sine an odd function? But why is sine odd? Which means that sine of minus x equals minus sine of x. And what I'm going to do is I'm going to take the definition of sine and cosine in terms of SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, and I'm going to explain why that definition leads to these algebraic properties. Either cosine of minus x equals cosine of x, or sine of minus x equals minus the sine of x. So to do that, I'm going to draw some triangles. Let's do that. I'm going to add a page here, and we're going to draw some triangles. And I'm going to look at triangles to make things a little bit simpler for us. I'm going to look at triangles that always have a hypotenuse of 1. So triangles with a hypotenuse of 1. And if you look at all the possible triangles that have a hypotenuse of 1, it's like you have a meter stick, a stick of length 1, and you're making all these different triangles with it. You're swirling it all around. It will make a circle. So if I keep one end of the meter stick here, and I imagine the other end of the meter stick over here, right? And this is length 1. And I'm going to make a triangle by having, something like this and something like that. And if I changed, I changed where the meter stick was. If I changed the angle, that is going to lead to a big circle like this. Okay. And here's the fact about sine and cosine. If I have this meter stick of length 1, I'm swinging it around, and I make an angle, let's call the angle theta here. And as long as this meter stick is length 1, so this is a length 1 meter stick, 1 meter. Let's just say 1 unit to not get into meters and inches and whatever. Then, because of SOHCAHTOA, because sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, the length of this green segment, the vertical distance between this point and the x-axis, this vertical distance is going to be the sine of theta. Why is that? Well, sine is opposite over hypotenuse. The opposite side is this green length, and the hypotenuse is 1. Dividing by 1 doesn't do anything, so this length must have been sine of theta. So sine of theta equals opposite over hypotenuse, but hypotenuse is 1, so it's the length of the opposite side. And the thing you got to keep your eye on in this particular case is that it's the length of the opposite side as long as you're above the axis. If you're below the axis, it would be negative. So more accurately, instead of saying sine is the length of the opposite side, I'm going to say sine is the displacement of point in the y direction. And so to really show you what I mean, I'm going to take my picture and I'm going to draw the mirror image of it. So let me do it in this pink color. I'll do the mirror image, so all the way down to the circle. So will still be length 1, and this is going to be the angle, not the angle theta. This is the angle negative theta, and it's negative theta because we're going down. So that's the angle negative theta that is illustrated there. And if I drew the thing correctly, I would be able to extend this down here. Okay, so look, I drew the angle wrong. Let me fix the drawing. Okay, let me try one more time. So here is the mirror image of the point. Here is the angle negative theta. This is supposed to be a 90-degree angle in all cases. 90 degrees here and here. My dog is whining to leave, so I will go let him out. Pretzels, come here. Go. Okay. So I've drawn the negative, and this is the thing you got to keep your eye on. This is the really important bit. Let me do this this thing in a green color, but a different green color. Let's do it in a nice light green color, and let's do it filled in. Okay. This distance, as a distance, of course, is the same as the distance before. But the sine of the angle, the sine of negative theta, right? It is not the distance, it's the displacement. And what's the difference between distance and displacement? It can be negative. And in fact, in this case, it is negative whatever that length is. So it's the sine of negative theta is equal to negative the length of, I'll call it the opposite. Let's call it op for opposite. So the sine of theta is just the length of this dark green segment. That makes perfect sense. The sine of minus theta, it's not this length, it's negative this length. And that's because sine is always the displacement. It's not the actual height, it's the how far above or below you are. And because we're below, it's a negative. Okay, if you realize this, that the sine of theta is the length of the dark green segment, the sine of minus theta is negative the length of the light green segment, you are very close to doing what we wanted to do, which is proving that the sine of theta is equal to, and then we wanted to do a bunch of algebra steps here and get to negative the sine of negative theta. These two things are both equal, and they're both equal to the length of this side. But let's call this the length of the side. Length of side, which is equal to that. And the reason they're equal is because if you look at these triangles, it's the same triangle, just drawn upside down. So because this triangle on top is the same as the triangle on the bottom, therefore, the sine of theta is equal to minus the sine of minus theta. The sine of minus theta is the negative the length of that side. The sine of theta is positive the length of this side. So of course they're negatives of each other. They're both equal to whatever that length is. And that is the algebraic reason why sine of theta equals minus the sine of minus theta, meaning that sine is an odd function. Okay, so if you've never seen this before with sine, this probably is a little confusing. This is the unit circle definition of sine and cosine, looking at sine and cosine as the displacement in the y direction of a point on the circle of radius 1. So hopefully that made sense. What about cosine? Cosine is even easier. Cosine is even easier. And once again, cosine of theta is this length over here, right? The length of the adjacent side. The cosine of theta equals, it's the displacement in the x direction of point in the x direction. And in this case, because we're looking at an angle like this in the first quadrant, that is literally the distance. If we were looking at an angle like way over here, then the cosine would be negative, but in this picture, the cosine looks like it's positive, which is fine. What is cosine of minus theta? Okay, and again, let's do this in the bizarro light blue color. The cosine of negative theta. Well, it would be the displacement of this point down here. And it's the displacement, it's this distance, right? So the cosine of plus theta is the dark blue, and the cosine of minus theta is the light blue. It's the displacement of the point. Again, in the x direction. Okay, and look, if you just stare, you just look at this, the displacement of the dark blue and the displacement of the light blue are exactly the same. This triangle that is mirrored, this triangle over here is mirrored down here, that leaves the side on the x-axis the same. So the cosine of theta is equal to cosine of theta, oh boy. Cosine of theta is equal to cosine of minus theta because they're both equal to whatever this distance is, the length of the side. Length of side. Okay, and I guess I got it maybe to be crystal clear and not confuse it with the sine case. For sine, it was the vertical side, and for cosine, it is the horizontal side, That is why cosine is an even function, right? Because when we're talking about flipping the triangle vertically, and when you flip the triangle vertically, the cosine doesn't change. That's the length of the horizontal side. The sine changes by a factor of -1. That's the vertical side. That is why sine and cosine are even and odd. Okay, I think I've said it enough times. Let's stop there.